Thank you for giving me this opportunity to present our paper with title Toward an MQT5 Geolocation Extension for Location-Aware Application in the 44th International Conference on Telecommunication and Signal Processing. My name is Felicien Ihirwe, and I'm a PhD student at University of L'Aquila. I work for Intake Solution in the Innovation and Technology Service Lab. This work was conducted in collaboration with Giovanni Iovino, who is the head of FinTech business unit at Intake Solution, and Professor David DiRuscio, who is an associate professor at the Department of Information Engineering, Computer Science and Mathematics at University of L'Aquila, Italy. The agenda of my talk today, I will start by introducing the topic. I will continue by giving the proposed approach technical specification, and I will continue by giving an example scenario, and finally I conclude the presentation. Starting by the topic introduction, we see the current high adoption of high performance computing IoT systems. This is mainly due to the adoption of current trend of 5G networks. In IoT system, we know that the heterogeneity is already present in where the code runs. Some part of the system run at the edge level, other part run at the fog level, and another part of the system run on the cloud level. In some complicated IoT use cases, such as smart city, real-time data need to be shared, and also real-time decision need to be made. To make this wireless intercommunication effective, we require efficient communication protocol and the data processing mechanisms. In case of moving client, location information which come at real time need to be included in decision-making process. And we know that the location information comes as an additional burden to the message itself. Before continuing, let's first talk about MQTT. MQTT, known as Message Querying Telemetry Transport, MQTT protocol was established in 1999 by IBM as one of the primary IoT communication protocol. In 2014, MQTT 3.11 was being officially released by OASIS and referred to as the standard version of the protocol. MQTT aims at empowering the lightweight communication of different heterogeneous situations between low power constrained devices. MQTT utilizes a publish-subscribe mechanisms, unlike other conventional protocols that utilize request-response model, in this case HTTP, for example. To guarantee the best nature of its correspondence, MQTT utilizes 3 unique quality of service level to indicate the nature of administration. In this case, we can say fire and forget, quality of 0, quality of service 0, conveyed only single time, QoS 1, or conveyed at least once, QoS of 2. Finally, MQTT can scale up to billions of connected real-time devices. To give you a sense of how MQTT protocol work, let's take an example. A client, which is a publisher, publishes a message to the broker. The subscriber can receive the message dedicated to them. To satisfy the publish-subscribe on a fundamental level, MQTT utilizes a cloud-based dataset communication point referred to as topics and are used as links each time the client is interested in a particular data. The broker is a server-side application responsible for filtering topics, keeping track of publisher and subscriber. It is also responsible for sending messages to the subscriber, filtering the message and classifying the subscriber based on the topic of their interest. The third-party resource can connect to the broker for data storage or other processing purposes. When a new client publishes a message on the subscribed topic, the blocker forwards the message to any client that has subscribed to that topic. Before we go on to the technical specification, let's first talk about MQTT5. MQTT5 was being released in 2018 as a free and open for contribution. The aim of MQTT5 was to increase its robustness, transparency, and extensibility. More than 20 major updates have been included in the release, such as session and message expiry, giving the power to the publisher to specify the time in which the message would be expired, in which there is no interested subscriber. And also the publisher can specify the format of the payload, and also the user property in which the publisher can send the specific message to the subscriber with known only between the two parties. Other the list update can be found in details on their technical website. But the question remains, what if a client only wants to publish to a specific location or subscribe to the message that are published to a specific location? So in this way, we propose a new extension of MQTT5 based approach, which will consider the geolocation information from the publisher and the subscriber. We will present operational rules which guarantee the back compatibility with the client that does not use the proposed extension. We will also present technical specification which will ensure scalability and robustness. Before going forward, let's first talk about the MQTT control packet. MQTT relies on a sequence of packets referred to as MQTT control packet to send the messages. MQTT control packet is divided into three main parts as represented in this table. The fixed header is obligatory and fixed, and also is used to specify the packet mandatory behavior information, such as packet type and length. The variable header, on the other hand, is used to specify optional behavior of the network. This part is variable and can also be used to specify payload content characteristics. The payload field contains the message to be conveyed. For this research, we will focus only on the variable header part, as is the basis of our extension. As for the last release, the variable header structure varies depending on the packet type. So the current and the typical structure of the variable header is shown in table 2. MQTT5 have defined several types of the property, and each of them has its standard identifier. Our approach relies on investigating the possibility to extend the variable header field called user property and help carry additional UTF-8 string pair containing information such as geolocation data, in this case GLP, data that the client can use as one of the facts when receiving or sending the message alongside the topic of interest. Note that each property in MQTT, as we say, has unique identifier. In this case, user property identifier have 0x26 hexadecimal format. The length of the packet, GLP packets, is calculated as a sum of each GLP size plus n identifier bytes. This slide contains the operational rules which will be used to guarantee back compatibility with the client which does not use the proposed extension. The main rules is that a subscriber who needs to use the proposed extension needs to specify the GLP information by using the user property field. The same goes to the publisher. Also, the broker needs to use the information provided in the GLP payload to select the subscriber of interest. Finally, if the message is published by the client without GLP payload, that means that client need to publish to all the clients, public permission to all the clients which have been subscribed to that topic. If also the client subscribed to a topic without specifying the GLP payload, that means it's going to receive all the messages sent to that topic. The structure of a GLP payload is just a set of UTF string pair holding name value tags to be passed in the user property. The first string pair is GLP current position, which specifies the current position of the client specified by latitude and longitude values. The other type, the other value is a GLP area type, which have ID specify the area type, of course, and have the ID units of value to specify if the client is interested in the message of that area or not. And finally, the area data. The area data can differ depending on the type of the area. In our case, we have defined 5 types of the area. In this case, psychostatic, which is a static circular area with a fixed center or a remote center. A psychodynamic is a circular area with the center at the current position. The same goes to the rectangle static, a rectangle area in which it has a remote arbitrary center in width and height. The same goes to rectangle dynamic with the current position as the center. And finally, GLP line, which is just a set of line on the point. The next slide shows the definition of different area data. And for static cycle, the client only need to add the information of the center because it's arbitrary in the radius. Center dynamic, psychodynamic, it uses the current position as the center and then only to add the radius. The same goes to the rectangle. You need to add the width and height. And also the center, the arbitrary center. The same for rectangle dynamic. There is no need to specify the center because the client current position will be used. The GLP line, we can have 3 types of point: the starting of the line or the point on the line, and the end of the line. This is the intermediate point on the line. The interesting thing is that on the start of the line, that's where we need to specify the thickness. This slide contains an example scenario in which a client is at position 0 and wants to subscribe to the current position we defined this way. Want to subscribe to the cycle C2, the big cycle with radius R2, and they want to subscribe to the rectangle R1 with the height and width W1. Can be defined in this way. Cycle C3, which is a static cycle here with O3 and R3, and can be defined in this way. And rectangle R4, which can have width 4 and height 4, and a center of 4, can be defined in this way. And finally, a line from A2 to B2, A1 to B1, and can also be a line start with the thickness T1 and line end with no thickness because it will use the same thickness as T1. And note that there is no middle point. The next line A2 to B, A2 through B2 and to C2 with thickness T2 can be defined in this way. Finally, the client can exclude the area by making the all value 0. So, as to conclude, we have proposed an extension to the standard MQ-55 that will simplify IT system design and development. In case of client position management is crucial. We have presented the approach that will permit the message delivery by not only respecting the topic of interest, but also to the client positions. We have presented different operational rules to guarantee back compatibility And also we have depicted the different area definition mechanisms, which we consider different basic shapes. Thank you for your attention.